We're gonna multiply polynomials. Right, this is like we said, a linear, so the first power, a linear monomial, a linear binomial. Yesterday we said that when you add and subtract, you guys wrote down that exponents never change when you add and subtract polynomials. Do you remember writing that down? Okay. When you multiply, they do. So when we multiply variables, the exponents will change. So if I have 3x times 2x, do you know what I get?
6x.
6x what? Yeah, 6x, because x to the first times x to the first is x squared. And then you can only add and subtract like terms, right? But you can multiply anything. So 3x and 5, they're not like terms, but I don't care. I can multiply them. 3x times negative 5 is?
Negative 15x.
Negative 15x. Now what order is that in?
Ascending.
What?
Ascending.
Is it going up or going down? It's descending, and we call descending order standard form. So our answer here is like we want it. It's in standard form, descending order. All right, let's look at this one. Again, I have a linear monomial and a linear binomial. Anytime you're multiplying with a binomial, you're doing the distributive property, so to speak. So even when we multiply binomial times a binomial in a few minutes, I'll show you what we do there. 5x times 2x is?
10x to the second power
Good. And 5x times 1?
is 5x.
5x. Again, descending order. What do you think most people who mess up do here? Since it's the distributive property.
They
Don't put the
square.
2. Or
They don't square it, or they
mess
don't
up.
multiply the 1 by the 5x. They'll just put a plus 1. Remember, everything in the parentheses gets multiplied by that 5x. And you're right, a lot of times they leave off the square. Alright, now you need to copy this down. And I think some of you have done this before and some of you haven't. But when you multiply two binomials, you use what's called the FOIL method. When you multiply two binomials, we use the FOIL method. FOIL is an acronym. It stands for first, outer, inner, last. Now, if you had Miss Sutton, which that's 2 of you guys, right? Then you guys foiled. Don't remember? Okay. Oh, 3, you were here, weren't you? Is that all?
Yeah.
So y'all don't, no, the 3 of you. Alright, what about if you were at one of the other schools? Did you guys remember foiling?
I remember the
Yeah, I
word.
remember.
You do remember a little bit? No, you don't
Yeah.
remember a little bit. Okay. Well, it's very simple. It's like doing the distributive property twice. Alright, if you'll copy this problem down, I'm going to show you what we'll do. Alright, these are considered the first terms of the two binomials. So draw your little arc there, connecting them. So x times x is?
2x? No. 1x?
X squared.
I don't
X
know.
squared.
Yeah. X plus x is 2x. X times x is x squared. These are considered the outer terms. They're on the outside. So negative 5 times x is negative 5x. If those are the outer terms, then the inner terms are right here. 4 times x is 4x. And notice what is said here about outer and inner terms. They are often what? Right terms. And are they? Okay. We'll get to that in a minute. And then last terms, if x and x are first terms, then 4 and 5 are last terms, and so 4 times negative 5 is negative 20. Now, if you couldn't remember what Miss Sutton did, she put little eyes right here and called him a Martian man. That still doesn't bring it back?
Mm-mm.
Okay, do y'all see the Martian Man? These eyebrows, eyes, nose, mouth, ears, chin, do you see it? I'm a great artist. I know y'all are enjoying that. But that's just her little way of helping to remember how the things go. Alright, oftentimes these are like terms. And I mean like most of the problems we do, those are like terms. So -5 and +4 would give us what?
Negative x.
Okay, -1x and then -20. Now my answer's in descending order. By the way, if we were going to classify this by degree and by number of terms, I would say it is a x squared. So what's that Q word?
Quadratic.
Quadratic. 3 terms. It's a quadratic trinomial. Now, in the last part of this chapter, we're going to learn to factor a lot of quadratic trinomials. That's going to be our main emphasis. Do you guys remember doing any factoring out a greatest common factor and that kind of? Did you do a little bit of that kind of factoring?
Greatest common factor.
Greatest common factor. I think you did a
Thanks.
little of that, which means you did a little of this multiplying. So, did you guys do any trial and error? Difference of 2 squares, perfect square trinomials, any of that sound, does that ring a bell? Maybe not, maybe not. Alright, so now, when do I use the full method? What did you write down? When is it used? When you're multiplying 2 binomials. That's how you know the full. Multiplying 2 binomials. Alright, so let's put that into practice here. X minus 1 times x plus 9. Now, at first, it really helps to draw those little curves. So, x times x is, again, x squared. You're going to see that a lot. And then x times 9 is 9x. And -1 times x is -1x. And -1 times 9 is -9. Do I have my like terms again? And again, yeah, you do. And you are going to have most of the time. So this will be x squared, and then 9 minus 1 is
8.
8x. Compared to graphing, writing equations, elimination method, substitution method, this is easy. Would y'all agree?
Yes.
Okay. Okay, let's look at 3x plus 2 and 5x plus 1. Again, a couple of linear binomials. Have you noticed that when you multiply 2 linear binomials, you get a quadratic equation? Got an x squared in it? And the reason for that is because of the first. X times x is x squared. So what is 3x times 5x? 15 x squared. Good. Outer, 3x times 1. Inner, 2 times 5x. Last, 2 times 1. When you finish, see if you agree with me there. Alright, again we have 2 linear binomials. Try it yourself, and I'm going to try to be quiet. Y'all do this one, and then we'll check it. First, outer, inner, last. It'll be easy to miss a sign, miss multiply, miss add, subtract, but that's pretty much all we could do wrong, I think. 2x squared plus 14x minus 36. Do y'all agree with that? Yes. Questions?
I screwed it up with the curves. I did it wrong. When I went first, I went underneath.
Now, don't get tricked on this last part. 4 times 4 is 16, right? Did y'all do 3/16? And negative 3/4 and positive 1/4 would be negative. What? What? What would it be? Heather, what would it be?
Wait, which one?
Negative 1/2.
Yeah. Negative 3/4 plus 1/4 would be negative 2/4, which reduces to negative 1/2. Are there questions about the fraction problem?
So we just multiply the bottom and the bottom and the top and the top.
Is there any way that will reduce?
3/16 doesn't. Alright, here's some to do for dollars, so go ahead and go ahead and start on those, and then I'll draw for dollars. Okay, so first is 2x squared, outer is negative 5x, inner is 8x, last minus 20, and those combine together to get 3x. That is great, good job. Okay, let's do the next one.
I think this we did the last one.
I think so too. You didn't do one?
I don't remember.
This is what I had on my paper.
You did great so far.
I know part of it can make sense.
There you go. That's good. Alright, so 2y times 3y is 6y squared. Half of 2y is 1y. 2/3 times, well, I got lost. 2/3 times 3, the 3's cancel, leave me with negative 2y. And on the last, the 2/3 and the 1/2, the 2 over 6 reduces, or you could think about it cross reducing, and the 2's cancel out and leave you with negative 1/3. So these combine to give me negative 1y in the middle, 6y squared minus y minus 1/3. Do you guys agree? How many of you got both of those right? Does anybody have a question? That was everybody, that was good. Okay, try, well, I think we'll do this together, because you know how this one's different? It has
No,
two
Yeah, two variables.
two variables in it. Okay, now let me ask you a question. Is x times y and y times x the same thing by the commutative property? You guys remember it doesn't matter x times y or y times x. Alright, so copy it down. And then we'll do it together. Alright, first, 3x times 2x is 6x squared, just like it has been. The difference is going to be your outer, inner, and last. Outer, 3x times y is 3xy. Enter 2x times negative 2y is negative 4xy. Because 2 times 2 is 4, and then times x and times y. Does that make sense? If that makes sense, we're home free. Alright, and so then last, and here's what I will oftentimes forget. I'll say negative 2 times the 1 is a negative 2, but also the y times y is another squared. It's y squared. So when we have two variables in the problem, we'll have two squares down here in the answer. We will combine like terms. A positive 3 and negative 4 is a negative 1xy, and you can write the 1 or not. You might look at that answer and say, but is that in descending order? Here's the answer to that question. It is, because when you have two variables, which one do you think you would look at to put the answer in descending order? The one that comes first in the alphabet. So if I have a times b, what exponents am I going to look at? The ones with the variable a. If I have x and y like I do here, what variable will I look at? X, because it comes first alphabetically. So I have an x squared, I have an x to the first, and I have an x to the 0. I don't have an x at all, right? So this is in descending order with respect to x. And that's what I wanted. Alright, questions? That one's kind of different. Does it make good sense?
Yes.
Great. Alright, let's copy this down. This is some special cases.